Okay, U10. Just a quick lesson on today's work or this week's work. It's very important because this is the one that has. Oh, can I draw on here? Oh, I can too. Wow, I didn't realise that. Beautiful. So, uh, this fractional indices is really important. It's the key to Year 11 and 12 work. So, this exercise 2I we need to really focus on. We're going to do some more work from a Year 11 textbook as well, because fractional indices and index laws are really important for when you move into Year 11 advanced work. So what are we doing? Today, we're going to work with fractional indices, understand the fractional index law, and simplify index notation, moving between index law, index form, and surd form. Okay, so let's have a look. So here's our exercise 2I. But first, let's write down our new index or our index results, which we already know, or index laws. So we already know, oh, goodness me, we already know a to the m times a to the n. Don't write these if you've already got them. Oh, a to the m, we add them, a to the m plus n. And a to the m divided by a to the n is a to the m minus n, and a to the m to the n is a to the mn. And we have our index results. But we learnt last lesson, a to the negative n, that negative just means 1 over the top. Just means put it in the denominator. Now we're going to do some fractional ones. So a to the 1 over n is the nth root of a. So let's have a look at how that works. And I'm just going to have a look and see how they explained it. Hopefully they used the pattern again. Okay, so they use their surd law, so that sort of makes sense. So for example, if I had 2 to the power of something times 2 to the power of something that was the same, equaling 2 to the power of 1, that means 2x must equal, because I can add those, actually I'll do that first, that equals 2 to the x plus x equals 2 to the 1, and 2 to the 2x equals 2 to the 1, and then I can equate the indexes since the bases are the same, so 2x equals 1, therefore x equals a half. And by the same token, I could do 2 to the power of x times 2 to the power of x times 2 to the power of x is, let's say that equaled that. That means I'd get 3x's equals 1, which means x equals a third. Okay, so if in this case x equals a half, and my original statement was this, well, that means 2 to the power of, that must be 2 to the power of a half times 2 to the power of a half equals 2 to the power of 1. Okay, that makes sense. Well, what two numbers multiplied by themselves equal 2? Well, I'd have to go, the only numbers that multiply themselves are the square roots. So therefore, 2 to the power of a half is the square root of 2. And by the same token, what three numbers when multiplied by themselves equals 2? Well, that'd have to be the cubed root. Oh, I'll put a 3 in there. The cube root. So 2 to the power of a third equals the cube root. So this number on the denominator, in the denominator here, tells us the root. So if I have 2 to the power of 1 on n, 2 to the power of 1 on n that means I've got the nth root. Oh, and look, I put a 3 in there again. All right. So if we understand that in a fraction, and here's their explanation here, doing the same thing. Okay, you can get the nth root. Now, we want to be able to write all that in one go. And we've already done this. We did this in index notation before. So we can write now a to the power of m on n, because we know that the top number tells us the power. We already did that. So we're going to get the nth root of a to the m. Now, if we do all of that together, if we do a hamburger with the works, with the lot, we make it a negative. So that says 1 over the top of the nth root of a to the m. And there, if you remember this one, you get all these 3 laws for 1. Yeah? So you don't have to, so if you remember what each of those things mean in that power, the negative, 1 over the top number, the power, the bottom number in the denominator, the root. You'll be all right. So let's have a look at some of these questions. I'm not too fussed about question 1. All right, you can go through and do those. They're pretty easy. Here, just use your calculator for those. All right, and the same with here. So when you're doing these ones, you got to know how to do. We all know how to do the square root. But say, for example, I, which is the 4th root, on your calculator, you have a button here, but you have to hit Shift and this button, and then you can get whatever root you want. And we want the 4th root, so we put a 4 in there, and we go down. 4th root of 16, that's 2. All right, let's go back and do the 4th root of 81. So I'll go Shift and that button again. I could have just used my back arrow. The 4th root of 81 is 3. If I do question 3, so the cube root, so Shift, I need the cube root of 7, and I know there's a cube root button, but I wanted to use that just in case you get some other ones. Make sure you're out from underneath the radical sign before you go times, and that's what that dot means. All right, hold on, no, that's just asking us to do it. So the cube root of 7 is that, so 1.91, and if I go 7 to the power of a third, 7 to the power of 1 over 3, you get the same number. And that's what they're trying to show you. All right. So let's have a look at question 4, because that's when we start getting to the areas that are important. So question 4. So it asks us to write the following index notation. So 4a, well, that's the square root of 29. Square root of 29, well, that's 29 to the power of a half. If I do b, I got the cube root. So the cube root of 35, well, that's to a third. So 35 to a third. And this is the important part. You really need to be able to do this. By the time we're getting to c, we've got a numerator, a power and a root. So I've got the 5th root of x squared. Now remember, it's x. This number goes in the numerator, and this number goes in the denominator. Yeah? So if you remember that, you're okay. So it's 2/5. And remember, you can use your calculator to check this. You can put in any number and see if they're equal. So that's what they're trying to show you in the previous question. So you go, oh, the fifth root, let's make a number. I always pick 7. So the fifth root of 7 squared, wonder what that'll be, 2.17, 2.1779, so 2.2, just remember that number. And let's go 7 to the power of 2 on 5. Oh, look at that. Because it's the same thing. Remember, you can check these. That's why I told when you did your cert exam, you checked it. So you go along and try those. Remember, you've got to include the number. So I'm going to go and skip now to G. And I've got the fifth root of 10t squared. Now remember, the 10 here is not squared. So I'm going to write these separately. That's 10 to the power of a fifth, because it's not squared, but the t is squared and the fifth jumps in there. You should be able to do h the same way. So I've got the 8th root of 8m to the 4. Now remember, the 8 is not raised to the power of 4. Only the m is. So it's 8 to the 8th m to the 4 on 8. But remember, you can simplify that. So it's 8 to the 8th, and that's m to the half. Now, if you're being really smart, you would go, oh, 8 can be written as 2 cubed to the 8th. By the way, I'd be happy with that answer. And I've got my m to the half. I don't know what Margaret's got written in the back. The book has got written in the back. So that's, I multiply those and I get 2 to the 3/8 m to the half. All right. Third form, they're pretty easy. I'll do the first and last for, oh no, question 5. Again, question 5 is important. So I'm going to create some space here because I want to be beside the question. So hopefully you've had a look at those. So question 5. 5a. 7 root x to the 5. Well, that 7's got nothing. It's just hanging out the front. It's just a 7. The x, however, is to the power of 5 and it's a square root. So 7x to the 5 on 2. I'll quickly do b. You should get really quick at these. 6 cube root of n to the 7. Well, the 6 has no indices working on it. It's got a 1 at the top if you really wanted to put it in. Your n is a 7th of the 3rd. So now I'm going to jump down to f, 2, the 4th root of g cubed h to the 5. Again, 2's got nothing happening to it. The g has a 3 on 4 and the h has a 5 on 4. Now, the last 3, they're very important. I'm going to start you off. You try and have a go yourself, but I'm going to start you off. So I'm just going to write it in index notation, so 5 root 5. Now, I could be smart and just multiply my third back in, but I'm just going to write, well, that's 5 to the 1. That's what that 5 is equal to. That 5 is 5 to the 1. And the second 5 is 5 to a half. That's what root 5 is. Okay, and remember they're multiplied. Oh, if they're multiplied, I can write them, I can add the powers. Now, you're all going to want to write, 5 to the 1 1/2. Don't. Don't write 5 to the 1.5. It doesn't tell you what you need to know. Yes, I know it's correct, but what you want to write it is as an improper fraction, 3 on 2, because that tells you so much more. It's the square root of 5 cubed. Having it in this form, although correct, is not as good as having it in this form. So 5 to the power of 3 on 2. What are we up to? 7 root 7 will be the same. I want to do I. You go and have a go at it. See if you can do it and then come back. It's 4 cube root of 4. So that's 4 to the 1 times 4 to the third, which is 4 to the 1 and a third. Remember, I don't like to write it like that. I like to write it as an improper fraction. 4 to the 4 on 3. Let's just write that as a better fraction. 4 to the 4 on 3, which means it's the cube root of 4 to the power of 4. They're really important. Make sure you can get those. Question 6. Question 6. So when you're doing these, make sure you're setting them out properly. Make sure you're getting them right. I probably should get my answers up as well. You can always check with your calculator anyway. So question 6. Expressed in third form. So it's just going back the other way. So 6a, 2 to the 5th, equals the 5th root of 2. Well, let's jump down to some harder ones. Let's go straight to F. 7 to the 2/3. Oh, that's a cube root of 7 squared. G, 2 to the 3/5. Well, that's a 5th root of 2 cubed. Make sure you're writing these properly so that I noticed someone in their exam would write this, and that's not right. You've got to have this number smaller and in there. So make sure it's really obvious where that is. The last one, 3 to the power of 4 on 7, so H, 3 to the power of 4 on 7 is the 7th root of 3 to the 4. Okay. Now, even though, and someone sent me an email and said, can I have some help with these? Don't worry, do them on your calculator. Do them on your calculator. But I am going to do them, or do a couple. Unless you know your powers really well, you're going to have trouble with this. And you only get good at that by doing heaps and heaps. So yes, have a go without a calculator, but try them with a calculator. So here we go. So 7a. Now there are lots of ways to do this, but I'm going to write, so 36 to the power of a half. Well, 36 is 6 squared. Right, so I've just replaced the 36 with 6 squared. And I've gone, I can multiply those brackets. So it's going to become 6, and 2 times a half is 1. You could have also thought about this, that's a square root of 36, and you know that's 6. Doesn't matter which way you do it. B, 27 to the 3rd. Well, you can go, that's a cube root of 27. And if you know your cube roots, you know that's going to be 3. By the way, your cube numbers, you should know your squared numbers. 1 squared, 2 squared, 2 squared, 3 squared, 4 squared, 5 squared, so on. Your cubes, I think I know up to about 5. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, and that's where I stop. I think the next one's 249. Was it 7 cubed? 343. Yep. Righto. So 49, square root. So going through those, I want to get to the negative one. So let's have a look at I. 81 to the negative a quarter. Well, that's just 1 over 81 to the 4. And remember, that's the fourth root of 81. Now, I don't expect you to know your fourth roots, but you could go, 1 on 81. Well, 81 is 9 squared. So 9 squared to the power of 4. 1 on 9 to a half, because 2 times 4 is a half. That should be a quarter. And 2 times a quarter is a half. That should have been a quarter there. Sorry about that. Therefore, you now know that you've got the square root of 9. So that's the square root of 9, which equals a third. So remember, the 1 tells you the negative tells you it's 1 over the top. If you can't do it, then you can do that bit on your calculator. You don't need to know your fourth root, but you can rewrite 81 as 9 squared. And 9 squared, multiply that, you get a half, and you know the square root of 9 is 3. Okay. If I go to J and L are pretty easy, because you're going to be getting rid of the numbers, but I want to look at K. K to the negative a half, 400 to the negative a half. So K, 400 to the negative a half. Well, remember, the negative just tells you it's 1 over 400 to the half. So you've got to find the square root of 400. Well, I do happen to know my 20 squared is 400. So it's 1 over the square root of 400. And if you don't know your square root of 400, you can use your calculator, but even though it says not, 1 over 20. And then you can check on your calculator. So go, 400 to the power of negative a half. All right? Did I put a 1 back there? Negative a half. And I should get a 20th. And if I write that as a fraction, there we go. So you can check these on your calculator later just to make sure you're right. Remember, you are never going to do you do your HSC minimum standards. There's a bit of non-calculator work there. But every test you do now will have a calculator. So question 7, so that's just going to be 1 over the fourth root of 10,000. That's going to be 1 over the third root of 1,000. Now, question 8. Again, this is good practice for when you do not have a calculator. And if you're looking ahead to question 9, you can't do them with a calculator because they've got algebra in them. So it's good to be able to know your laws here. So question 8, what do we got? 8 to the power of 2/3. Now you may need to know a couple of powers. So this is where understanding different powers will become useful. And in the next exercise we do in our Zoom meeting tomorrow. So let's have a look at 2. 2 to the power of 1, 2. 2 to the power of 2, 4. 2 to the power of 3, 8. Well, that's going to come in handy over here. 2 to the power of 4, 16. Notice I'm doubling these. 2 to the power of 5, 32. 2 to the power of 6, 72. I should have 64 in there. Have I done something wrong? 2, 4, 8, 16. Sorry. There we go. 2 to the power of 5 is 32. 2 to the power of 6 is 64. Now, if I do 3, my 3s, and I go 3 to the power of 1, 3. 3 to the power of 2, 9. 3 to the power of 3, 27. 3 to the power of 4, 81. And that's where I stop. And if I'm looking over here, most of these, yep, that's all you'll need. You'll need your 5 squared. You'll need your 4 cubed. Your 4 cubed for 64. So the other one is 4 to the power of 1, 4, 4 to the power of 2, 16, 4 cubed, 64. So knowing that, let's go on. So 8 to the power of 2/3. Well, I can write 8 as 2 cubed. And then when I multiply those out, the 3's will cancel, which means I get 2 to the power of 4. 2 to the power of 2. I was one step ahead of myself, which is 4. You could do that another way. You could go, but that's the way they're asking you to do it. You could go, oh, that's the cubed root of 8 squared, which is the cube root of 64, which, because you know this over here, it's going to be 4. So you could do it that way. The next one, B, 32 to the power of 3/5. Well, if you know this one over here, you got it. Because it's 2 to the power of 5 to the power of 3/5. The 5's will cancel when you multiply them. So you get 2 to the power of, I'm just going to write it just in case people don't understand what's happening. The 5's will cancel, leaving me with 2 to the power of 3, which I know is 8. Okay. D. 16. So D's another power of 2. Right? D's another power of 2. You're going to be using this one. You're going to write 16 as 2 to the power of 4. The 4's will cancel. You get 2 to the 5. So I'll do it. D. 16 to the power of, was it 4/5? 5 on 4. 5 on 4. Well, that's 2 to the power of 4. 5 on 4. Multiply the powers because it's the power of a power. 4 times 5 on 4. The 4's will cancel, leave me with 2 to the power of 5, which is directly above and is 32. Righto. Let's get down to the bottom. Let's try 64. No, let's try F. So F is 27, so that's a power of 3, negative 2/3. Now, you can write it up straight away, or you can just go, all right, I'm going to write 27 as 3 cubed to the negative 2/3. The same principles apply, so that's going to be 3 to the negative 2. Remember, the negative just tells you it's 1 over the top, so 1 over 3 squared, and 3 squared is 9, so 1 over 9. And you double check that, go to your calculator and you go, 27 to the power negative 2 on 3. Beautiful. Here we go. I'll do J, K, and L. I'll do J, K, and L. You go and have a go at them, see how you get through them, but I'll do J, K, and L. They look to be a little bit tougher. Okay. J. I've got 2 on 4 to the power of 5 on 2. Now, There are several ways you can do this. I'm just going to leave that 2 on top. I'm going to deal with this power underneath. I'm going to write 4 as 2 squared. I'm going to leave that 2 on top, and I'm going to multiply this bracket out here. And those 2's, those 2's are going to cancel. So I'm going to get 2 to the power of 5. Now remember, I've got a 1 there. So that will cancel with that, leaving me with 4 down here. And remember, I'm going to get 1 on 2 to the 4. And I know 2 to the power of 4 over there, slightly to the left. Can you see it? There it is, 16. So I'm going to get 16. 1 on 16. There are other ways to do it, but that's what I recommend you do. If I do K, so you can tell that this is going to be a power of 3 because you've got a 3 on top, and you know that the 3 is going to come into it. You go and have a go at it and see if you can do it before I do it. And I know these are hard, but you've got to persist with them. So K, what have I got? 3 on 9 to the power of 5 on 2. I'm going to leave that 3 on top. I'm going to write a 1 there for you. And I'm going to write 9 as 3 squared. I'm going to have the 5 on 2. What's going to happen to the 2's? When they multiply out, they will cancel, leaving me with 3 on 1 on 3 to the 5. That 1, 3 will cancel with that one, leave me with 1 on 3 to the 4, and I know my 3 to the 4 is 81. Okay. You can do L. It's just going to be powers of 10. It's exactly the same. Almost exactly the same. Now, all right, well, I'll do it. I know some of you are going to have some trouble. Go away and have a crack yourself. And then we're going to have a go at 9 and 10, which are going to be very difficult. So what have I got? L. 10 on 100 to the power of 3 on 2. Well, I'm going to leave that 10. I'm going to write it as a power of 1. I'm going to write 100 as 10 squared. And I've got 3 on 2 here. What's going to happen to the 2's? They're going to cancel, which leaves me with 10 to the power of 1 on 10 to the 3. I'm going to cancel that. And I'm going to get 1 on 10 squared. And 10 squared is 100. 1 on 100. Righto. Let's now get into some of these really difficult ones in questions 9, 9, and 10. Use the index laws. So 9a. A to the half times a to the 3 on 2. Well, add the powers. Oh, a half plus 3 on 2, add the top, 4. Don't add the denominator. Oh, a to the power of 4, that'll cancel down. 4 on 2 is the same as a squared. Let's do b. M to the 3 on 2 times m to the 3 on 2. Add the numerators, m to the 6. Do not add the denominators. Do not. Some of you be tempted. And that'll cancel down, leaving with m to the 3. So these are pretty easy. Oh, what about a division? Let's go to D. You try C on your own. A division, b to the 5 on 4 divided by b to the 3 on 4. Well, subtract the numerators. 5 minus 3 is 2. And leave the denominators alone. And that becomes b to the half. Okay. 9e, power of a power. S to the 3 on 2 times 4 on 7. Well, you just multiply the powers. So it's S to the 3 on 2 times 4 on 7. Now you can multiply those straight up and get 12 on 14. but wouldn't it be easier to cancel the 2 with 2 there? And instead of getting s to the 12 on 14 and then simplifying, you're just going to get s to the 6 on 7. Hopefully you know what you're doing there. F, y to the third to the third. Oh, it's a power of a power. I multiply those. Y to a third times a third. Y to the ninth. Multiply top and bottom. Okay. If you get G wrong, I'm going to freak out. It doesn't matter what's in there. It's to the power of 0. Anything to the power of 0 is 1. Anything to the, except 0. That's just going to equal 1. Goodness me. So hopefully you'll be able to do those. I'm going to jump now down to H. So I'll just create some space for myself. H, because I know you're going to have trouble with H. You just got to practice these. So go, make sure you're doing the ones in between. H. So here's H. So A, oh geez, that's a terrible A, looks like a 9. A to the power of 2/3 on B to the power of 4/3, and I've got to the 3/4. Now, each of these is multiplied by that. Each of these is multiplied by that. So what do I get? I get A to the 2/3 times 3/4 over B to the 4/3 times 3/4. Now, watch what happens. That 3 and that 3 cancel, and 2 goes into itself once and 2 goes into there twice. So on the top, I get A to the half. On the bottom, the 3's cancel, the 4's cancel. I just get B to the 1. Now, did they ask writing? No, they just use index laws to simplify. You could, if you wanted to, bring that B up to the top and write B to the -1, but I think that having it in this form is better. All right. Question 10. Simplify the following. These will be difficult. You're going to have a lot of trouble with these, but you've got to persist. You've got to struggle with it. So let's try a couple. And if you're still having trouble, come back and I'll do not all of them, but a fair few of them. So let's start. Question 10. Square root, so 10a, the square root of 25 x to the 4. Now, well, that's a square root of 25 times the square root. Let's write that as x to the 4 there. Well, 25, that's easy, 5. Oh, that's x to the 4 on 2. Oh, 5, that 4 and 2 will cancel. 2 goes into itself once, 2 goes into 4 twice. Oh, I'll just get x squared. The square root of a 4th power is dividing it by 2. Let's have a look at the next one. The cube root, B. The cube root of 27 t to the 6. So that's a cube root of 27 times the cube root of t to the 6. So cube root of 27 is 3. And that's just going to be t to the 6 on 3. Oh, 3t, 3 goes into itself once, and 3 goes into 6 twice. So again, 3t squared. All of these are going to be similar. You're going to know your fourth roots. I'll do d, the cube root of 125 t to the 12. Well, that's the cube root of 125 times the cube root of t to the 12. Well, the cube root of 125 is 5. You need to know that. Remember, we did it over here. No, we didn't. 5 cubed. 5 cubed is 125. And this is going to be t to the 12 on 3. 3 goes into itself once, 3 goes into 12 4 times, so I just get 5t to the 4. Okay, in all these ones here, you're just multiplying the powers. So I'll just do G, you have a go at the other two. T to the quarter to the 12. Well, you multiply those powers. T a quarter times 12. Well, a quarter of 12 is 3. H m to the 5th to the 10. You're going to find a 5th of 10 equals m to the 5th times 10. Ah, that's m squared. Okay. Let's have a look at these last ones. Again, in each of these, you're going to write them in powers. And the only one that's going to pose you some problems is this one, which is 7 cubed, 343. So I'm going to do J and L. You have a go at the other ones. So I'm going to do J and L. You have a go at those ones yourself as well. It'll be difficult, but you need to persist. So here's J. I've got 216 m to the 6 n cubed. Well, 216 is 6 cubed. There's no other way for me to explain it other than knowing your cubics. 1 cubed, 2 cubed. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, and 7 cubed, which I didn't know off the top of my head, was 343. I'm going to need that for the next one. So let's write that 216 in index notation. And by the way, this is all raised to the power of a third. So I'll write that as 6 cubed, m to the 6, n cubed, all to the third. Now, all those powers are going to be multiplied. So 6, 3 times a third, m to the 6 times a third, and n to the 3 times a third. Well, a third times a third, 3's will cancel, leaving me with 6 to the 1. 3 goes into 6 twice, so I'm going to get m squared. And the last one, the 3's will cancel, leaving me with n to the 1. And of course, when there's a 1, I don't need it. So 6m squared n. K. So 343 r to the 9, t to the 6 to the third. And again, I'm going to do the same thing. Again, I'm going to write 343 as 7 cubed, r to the 9, and t to the 6. Now, each of these their powers are going to multiply. So you get 7 to the 3 times a third, R 9 times a third, and T 6 times a third. I'm going to do this really quickly. The 3 is going to cancel. I'm going to get 7 to the 1. 3 goes into 9 3 times, R cubed. 3 goes into 6 2 times, T squared. Finally, I'll do N and P. So N, I've got the cubed root of 8x cubed on 27. Now, from your surd laws, you should know that's the cubed root of the top, 8x cubed, all over the cubed root of the bottom, which is 27. Well, that's pretty easy. I'll get the cube root of 8 and the cube root of x cubed. And the cube root of 27 is 3. The cube root of 8 is 2. So I've got 2/3. And then the cube root of x cubed. The cube root of x, it's just going to be x. 2x on 3. You could have thought of this as 2x 3 on 3, which will give you 2x on 3. So you could have gone straight to that step, which is probably how I would have done it. Finally, the last one I'm going to do. So what do we got? We've got P. And it's 10 squared, x to the 4 over 0.01, they're being tricky now, to the power of a quarter. All right, I want to really step this out. 10 squared, x to the 4, quarter, 0.01 is 1 on 100. You should know that, it's just a basic decimal law. 10 squared on x to the 4. Well, 1 on 100 is 1 on 10 squared. And 10 squared, x to the 4. I really wouldn't do all this working normally, but I'm doing it so you can see what my thought process is. It's 10 to the minus 2. Now, that negative just means it's got to come up the top. Yeah? So I'm going to get 10 squared x to the 4 times 10 to the 2. Oh my goodness, there is no more fraction. Yep. Why? Because when you, if I went back to this step, I've got 10 squared x to the 4 and a quarter over 1 on 10 squared. Now, what do I do when I divide by a fraction? I multiply by the reciprocal. So it's 10 squared x to the 4 times 10 squared on 1 to a quarter. Oh, and we get to this spot. 10 squared x to the 4, 10 squared. And I've got a quarter there. Okay. So that's going to be 10 to the 4, because I'm going to add these two powers, because they're multiplied. Note, I haven't even expanded the brackets yet. A quarter. And what's going to happen? 10 to the 4 times a quarter, x to the 4 times a quarter, which gives me 10x. Now, I know some of you are going to find these difficult. but hopefully you've been able to follow it. You struggled a little bit. You can, if you still have any more questions, email them to me. You can have a go at 11 and 12. There are lots of different ways you can do them. Down here you can see they show you two ways. I'd be going this way. I'll be going that way because that way requires me to know that number on my calculator, whereas here, or I'd actually do this. I'd be doing this. 16 to the 5 on 4 equals, oh goodness me, I've got an equal sign in there, equals, I'd be doing this way, 2 to the 4 to the 5 on 4, 4s will cancel, 2 to the 5, 32. I wouldn't do either of those two ways. I'd use my knowledge of the fact that I know my two powers, 2 to the 1, 2 squared, 4. Let's write it properly. 2 squared is 4, 2 cubed is 8, and 2 to the 4 is 16. That's what I'd be doing. Anyway, good luck with those.